Tokenization. Tokenization is one of the basic steps in natural language processing. Tokenization is the splitting of the tokens in a sentence into several tokens. For example, the sentence considered here, this is a sample, can be broken into four tokens, that is, this, is, a, and sample, as represented in the figure. The basic steps of natural language processing involve sentence splitting, tokenization, part of speech tagging, shallow parsing, named entity recognition, syntactic parsing, and semantic role labeling. Sentence splitting. Sentence splitting is the process of separating free flowing text into sentences. It is one of the first steps in any natural language processing application. A sentence splitter is also known as a sentence tokenizer, a sentence boundary detector, or a sentence boundary disambiguator. As represented in the diagram, we can detect whether there are a lot of blanks after a sentence, whether there's a punctuation, or whether there is words like etc. and leads to an end of a sentence or not end of a sentence. At the first glance, the process seems fairly simple, inserting a sentence break after every period, question mark, or exclamation point. However, abbreviations ending with period like any other words are more often sentence internal than final. Abbreviations are also an open-ended set, and a sentence splitter must be able to recognize domain-specific abbreviations when they occur with a final period. Moreover, question mark or exclamation point can exist at the end of a fragment embedded within a sentence instead of terminating the sentence. The sentence splitter is often uh, done by using an accelerator which performs grammatical error correction of English texts, also identifying errors in spellings, syntax, and punctuation. It analyzes complete sentences, and the quality of its output depends on having correct sentence boundaries. If a sentence boundary is not detected, then the accelerator will be presented with two joined sentences instead of one. This will negatively affect things like subject-object coordination. However, if a false sentence boundary is detected, example after an abbreviation, the accelerator will be forced to work with two truncated sentence fragments. The errors which may occur are of both type 1 and type 2 errors, which was discussed in the previous lecture video. The type 1 error is also the spurious detected false sentence breaks, and the type 2 error is the undetected correct sentence breaks. The type 1 errors that occurred were mostly false sentence breaks after abbreviations and personal initials, but there were also several after the periods in ellipsis. Several abbreviations appeared multiple times in the errors, indicating that the system did not recognize them but viewed them as sentence ending words. Many type 2 errors occurred when the system failed to split the sentences ending with quotation marks after the final period. There were also the quotation marks, for example. Now let us assume a sentence where in directed speech where the person says hi and there's a full stop at demarcating the end of a sentence, or let's assume there's an exclamation mark and there's a quotation mark. Hi, said Rahul. But the system detect what the system is expected to do is identify that the sentence ends after the word Rahul, but the system identifies the exclamation mark as the sentence ender and sentence terminator and ends the sentence here. Therefore, the quotation marks and the next two words are ignored. The type 2 errors, these were the type 2 errors. There were several cases of sentence ending abbreviations and personal initials similar to the example shown that were falsely considered as sentence internal abbreviations. In contrast to the type 1 errors, these appeared to be known abbreviations that the system could not always detect as sentence ending when that was exceptionally the case. The ER generator or the accelerator here is shown where the sentence is segmented and the paragraph is broken down, where the paragraph here is broken down into 7 sentences. A library contains libraries, books, authors, patrons. Libraries are described by lib name and location. Books are described by the title and pages. Authors are described by author names. Patrons are described by the patron names, and pat weight. A library can hold many books. The book can appear in many libraries. Breaking down this paragraph into multiple sentences, we observe that the generator does not end the sentence. Ideally, what we had seen earlier that was that after the first ending, the after the first punctuation, the sentence should have ended. But here we can see that the sentence generated is not stopped after the first comma. The thumb rule for or a heuristic rule for sentence splitting is period plus space plus capital letter. As we often know that the general format of a sentence ends with a full stop, and there's a space, and then starts with a capital letter immediately after that. So this demarcates a sentence here and a full stop, and this demarcates the end of a sentence because there is a space after the full stop, and the next word begins with a capital letter. Some tools that can be used for sentence splitting are Jasmine, Scott Powers Splitter, and OpenNLP. Tokenization. Tokenization is a splitting of the words in a sentence. For example, the sentence "the virus is contagious to our health" can be split into "the virus is contagious to our health." So we can see that each of the word is considered as a token and is split, converting a sentence into a sequence of tokens. These are the sequence of tokens. It's stored individually. So if the input is given as a string of containing words, it is broken down into multiple individual strings, which are then considered to be tokens. Why do we need tokenization? Because we do not want to treat a sentence as a sequence of characters. We want to consider them as a whole. As we know that the machine does not identify the human readable language and stores it in the form of binary that is zeros and ones. If without tokenization, the sentence would be represented as continuous sequence of zeros and ones, including the spaces in between. But with the help of tokenization, each word can be considered as a different token, and this helps in the efficient parsing. Now, for example, if without tokenization, when you're writing a Word document or any document, uh, if there was if the last, let's take the word the, if this was the last, if this word the, if this word the was the last word in a sentence, and instead of three characters there was place for only two, by a rule of the machine, the machine would allocate space for the first two characters, and the third character would be pushed to the next sentence or the next line. But if this entire thing is considered as a single token, if there is no space for the entire word, the complete word will be pushed to the next line. Tokenization issues: separate possessive endings or abbreviated forms from preceding words. For example, Mary apostrophe S can be considered as Mary's, something belonging to Mary, or something that Mary possesses, Mary has, something Mary possesses, Mary has, something that belongs to Mary, or something that Mary is. The first sentence can be related to Mary's dog. The second sentence can be related to Mary is a doctor. Third sentence can be related as Mary has a notebook. All these three sentences are completely different, and the use of Mary's is completely different in all three sentences. Now, the best approach to this would be separating punctuation marks and quotations from words. So, for example, if there's a full stop after Mary, it will be split into Mary, space, and then the full stop. If there's new, the word new within quotations, the quotations is separated out and the word new is taken as a single token. Tokenization divides the text into small units, usually words, removing punctuations. Challenges is what should be done with punctuations that has a linguistic meaning. As we saw in the earlier case, the apostrophe S could have three different meanings.